Geometry, Chapter 6, Section 1, Angles of Polygons. So there's a new object that we might have talked about it before. It's called the diagonal. And the diagonal of a polygon, it just connects two non-adjacent vertices. So it cuts through the middle of the polygon. Now what's really interesting about this is that the diagonals can actually make a bunch of triangles inside of the polygon. And you can see I've got a couple of examples already drawn out here for triangle, quadrilateral, pentagon, and hexagon. You can use it to divide up any convex polygon into a bunch of triangles. Now what's really handy about that is we know the interior angle sum of a triangle. And if you take a look here, on a triangle there are three sides. That's just one triangle inside of it, one triangle. And that means it's got a total sum of 180 degrees. On a quadrilateral, there are four sides, and it makes two triangles. And that, if you multiply 180 by 2, you get 360 degrees for the interior angles. A pentagon, it has five sides, and it makes three triangles, 1, 2, and 3. 3 times 180 is 540 degrees. Hexagon, 6 sides, 4 triangles, 1, 2, 3, and 4. And of course, 4 times 180 is 720 degrees. So what's kind of nice here is we can actually use this pattern here to establish a rule about the interior sum of any convex polygon. And it's called the polygon interior angle theorem. And the whole idea is if a convex polygon, it doesn't work on concave. Remember, concave is something like this where you can't even draw a diagonal that is inside, right? The diagonal's outside, so it doesn't work on these. A convex polygon with side number n, so the n is the number of sides, then interior angle sum is 180 times, well, let's take a look here at all the patterns. 3 sides, 1 triangle. 4 sides, 2 triangles. 5 sides, 3 triangles. 6 sides, 4 triangles. You see how you're subtracting 2 each time? You just take the number of sides, subtract 2, and then you multiply it by 180. And that's the sum of your interior angles. Let's go ahead and try that in an example. So part A, we're going to find the sum of the measures of the interior angles of a convex heptagon. Now, you might not remember, but a heptagon has 7 sides. You might have had to look that one up. And every once in a while you come across the name of one that you don't know. Just look it up in the book. It's in there. You could also just do a quick little Google search. How many sides is a heptagon? And it will tell you. So all we have to do is take 180, multiply it by the number of sides, subtract 2, and that gives us the sum of the measures of the interior angles. So 180 times 5. 180 times 5 is 900 degrees. So the sum of the interior angles of a heptagon is 900 degrees. Now, of course, you usually don't have to write it out in a full sentence like this. Most of the time, you're just looking for the number. But I just thought that might. It seems like it's so easy that sometimes people kind of get tripped up on how easy the calculation is. I wanted to give you a second to really let that solidify in your mind that that's what's going on. For part B, it's a little bit more complex. We have a quadrilateral ABCD, and we want to find the measure of each interior angle. So what we're looking for is angle A, angle B, angle C, and angle D. A couple of them, they already give us this information. Angle B and angle C are both 90 degrees. Okay, so that's going to be useful. What else is useful is it's a quadrilateral, so I know the total is going to be 180 times 4 minus 2. And we already talked about it before. For a quadrilateral, it's 360 degrees. So that means all four of these angles here have to add up to 360 degrees. Well, measure of angle A is 3x. Measure of angle B is 90. Measure of angle C is 90. And measure of angle D is x. So all of those things add up to 360. Combine some like terms. 4x plus 180 equals 360. Divide both sides by, subtract 180 from both sides. 4x equals 180. And then I divide by 4. 180 divided by 4, you can probably guess what it is. It's 45. So x equals 45. Now that's the value of x. It's not necessarily the value of any of the angles. It is the value of angle D. That's going to be 45 degrees. But angle A is 3 times x. So the measure of angle A equals 3 times 45, or 135. Equals 135. I should put a little m in front of all these things because they're all measures. So there are all my sides, or all my angles.